Hello guys, it's the question guy, and today we're going to be trying this question. In the diagram to the left, the volume of the ice is the volume, V ice is volume of ice, and V1 is the volume displaced by the ice. Prove that V1 is equal to the volume of ice melted. And if that doesn't make sense, when the ice melts, we want to prove that the amount of water displaced, like when the entire ice melts, will the water displaced be the same? Which means when this ice melts, will the water level rise? We want to prove that the water level doesn't rise, nor does it drop, but stays the same. So, what do we do? Well, with analyzation, let's do some basic things. First, from the state of floating or sinking, and Newton's third law, buoyant force of the ice, or just buoyant force, is equal to the gravity of the ice, which in turn simplifies to rho water volume displaced, which is volume 1, is equal to the mass of the ice. Now, with Archimedes' principle, where the buoyant force of the ice is equal to the mass of the water, which again simplifies to density of the water times volume displaced is equal to mass of water displaced. This is not mass water, this is mass water displaced. And again, this in this case is not volume displaced, but V1. So what do we do now? Well, in this situation, look, we have this twice, rho water V1, which is V displaced. So we can get from that mass of the ice is equal to mass of water displaced. Now, from this, let's try something. Let's take the cup, and then here's the water level. Let's make some theoretical object. This theoretical object, so theoretical object, so this object displaces the same water, it displaces equal water as the ice that we just had. So let's say now that our ice is now in this new container, I don't know, in a box or something. This is the ice. Then it becomes water in this box. Now think about it. In this situation, mass does not change. Right? Mass does not change. Therefore, mass of ice is equal to mass of ice is equal to mass of ice melted. Okay. Now, let's think about it this way. Mass of ice is equal to raw water, volume water melted. Or ice melted, actually, in this case. Okay? Now think about it. We just have this formula. That means raw water mass volume displaced, or volume 1, is equal to raw water volume ice melted, which is IM for now. Then we divide raw water on both sides. V1 is equal to ice melted, the volume of ice melted. And that's how you prove it. Thank you for listening to another video of The Question Guy, and I hope you learned something today.